Hello, everyone. Welcome to the Kuma community call. Please add your name to the attendee list and also feel free to suggest any topics for today's call. Today, we will see the demo of Kuma and Network Service Mesh, and we have an opportunity to ask a lot of questions to the Network Service Mesh community. But before, I'd like to take some time and congratulate everyone because last week it was Kuma Birthday. It's 3 years, so congratulations everyone. I think the project is moving with a great speed, so congrats. Also, I'd like to mention that next week there is a Conch Summit. So if you are in San Francisco by any chance, you can check this. I think it's very interesting, a lot of mesh related topics. So feel free to check the link. And also I wanted to mention that the last few weeks, we came up with 3 designs for the new policies, and 2 of them already merged for mesh traffic permission and for traffic log. And traffic trace is still in review, so you have an opportunity to make an impact how traffic trace will look like in the future. So feel free to add your comments. Yeah, and I think this is pretty much it from me, and I can stop sharing probably, and let's see the demo.
Hello, everyone. Give me just a second. I will
Vyacheslav, yeah.
open the demo. And you should see the screen with the presentation.
Yep.
Correct?
Yes.
Okay. So, hello once again. I am a developer at Storage Software Incorporated on a multi-service mesh project with the aim of integrating different meshes like Kuma, Istio, Console, Linkerd with our network service mesh. So NSM is the hybrid multi-cloud IP service mesh. It adapts traditional service mesh ideas to serve L3 payloads. It allows individual workloads running on pods, even in different clusters or clouds, VMs or bare metal service to connect to a common flat L3 network service. And it enables any traditional L7 network service like Kuma Istio Console to run over flat L3 with the operational simplicity of a single cluster deployment, enabling ultra simple multi-cloud, hybrid cloud L7 service mesh of your choice. So we thought about use cases that you can use with NSM, and one of that is using VMs and Kuma Kubernetes via NSM. So basically, you can have any kind of any amount of virtual machines somewhere, and you can connect them to the Wheel3 network, and can with the use of Wheel3 connect any pods on Kubernetes. So we also support these bare metals that use these data path providers like OVS, SROAV, VPP, and kernel. So about Wheel3, I will describe it like it is an implementation of virtual L3 network service. So generally, it allows to join different workloads to the same network and ping each other. Another use case that you can create is multiple virtual machines and bare metal server. So you can connect not only virtual machine, you can connect any kind of bare metal service that I described just before to the NSM network, and use the communications through NSM to ping each other, for example. So our motivation was to run Kuma over NSM Wheel3. We were just interested in this scenario, will it work or not? And it worked. So another one is use Kuma use cases with virtual machine. And so it will work on different network configurations. And another one is add to Kuma a possibility to work with NSM clusters. So about the configuration itself that I will show you, here's the diagram for it. So basically on the first cluster, we have NSM, Wheel3 endpoint, pod with the Kuma control plane, and our network service client pod with the workload that will be Redis database and of course NSC and the Kuma sidecar. And the second cluster will have pod with demo application. So basically front page that uses that we can view and the server that sends request to the Redis database. And in general, we can accomplish this configuration even when we use virtual machine instead of workload 1. So basically cluster 2 is just a representation for easier demo setup, and you can switch workload 1 to, for example, to virtual machine. So first, workload 1 dials workload 2 via sidecar. Then a request goes from Kuma sidecar to Wheel3 NSC. After that, it is based on configuration, goes to Kuma sidecar on workload 2 pod. And then it just goes to workload 2 itself service. Yeah, so let's switch to the demo itself. I will show you. Currently, we have 2 clusters with the presetup and NSM. Then we just have to apply configuration for Wheel3. Is font large enough to be seen? Okay.
Looks good for me.
Yes, so network service endpoint is running. After that, we should install Kuma CTL, but I already have it, so I will skip this step. Then we have to create TLS certificates and apply them for Kuma system namespace. Yes, so after that, we can create based on this configuration, the TLS certificates, our configuration of control plane and apply it also. Let's give it a minute to start up. Here it is. Yeah, so it started up, it should be running. After that, we can apply our configuration for workloads. Redis database should be running in a moment.
Question, I see 3 containers. So one is Redis itself, right? Second is Kuma sidecar. What is the third container?
And the third one is our network service client. So basically our sidecar.
Okay, I see.
So yeah, it started. Then we should start up our front page on the second cluster. And it should be running just a moment. Yeah, so we can put forward from this page and test if it works. In the response, it should give us no errors. Yeah. So we can also go to the page itself to test it. It's just a basic demo that you guys have provided on your website. And we can also check that I will close it so it's not spam. We can also check your control plane. It should show us that it sees both of the data planes and both of the servers. Yeah. So it shows that it is online, and we can also check the logs from this service. Give me a second, I will copy paste it into the comment. Yeah, so it shows us that it is connected through this address and the port that is used in Kuma sidecar configuration. So basically, even though it is on the second cluster, it thinks that it has connection to the first cluster locally. So cluster 2 has no other ways of connecting to cluster 1 except NSM connection. Yeah, so basically that's it about the practical side of the demo. Here's the links to the examples. We have already merged it into our repository, and I have created a pull request into Kuma Tools repository just to replicate that we have integration. Yeah, so we thought about future plans, and currently we want to implement the integration for Kuma, not for Kuma Universal, which was used actually in this demo, and integrated with VMs and bare metal devices via NSM. You can comment this presentation if you want to offline, or you can just ask me some questions, and if we don't answer them, I will be sure that they will be added here with the answers. So basically that's it.
Hey,
If any, yeah.
Yeah, I have a first question. Okay, go ahead, Charlie.
Yeah. Oh, well, first, thank you very much. That was quite interesting. Could you explain a little bit more your point in future plans? Because you talk about Kuma and Kuma Universal, implement integration for Kuma and not Kuma Universal. I'm not really sure I understand this point.
So give me a second. So currently we have this configuration for the control plane. So it runs in universal mode. And of course it stores in memory. Yeah, so we want to just reduce amount of work and use Kuma, default Kuma, to work with VM clusters, VM machines. Currently, it can be done over if we use universal setup. So it will run on the on the virtual machine. For example, we have to create data plane config and run it like you show in your documentation. So we want to use default Kuma to reduce the amount of work like this and to implement it just automatically, I believe. So there no need to add this configuration in future.
Okay, I get it.
Yeah, I just want to say that that was basically my question. Like, how did we get the sidecar in a cluster without the control plane? But now I know. Maybe you can share, so about these future plans. So let's say we want to integrate this with Kuma with sidecar injection. So maybe the question is, how do you see it done in other meshes? Maybe, like, are you planning to point every Kubernetes cluster to one cluster with the control plane, or how do you see this?
So one thing to realize is that with network service mesh, we're not as cluster bound as people typically are, because we actually have the ability, say that I have a workload that I need to plug into a particular Kuma instance that's running in some cluster that's got an entirely different service mesh setup going on. That's doable. We also have the ability to federate trust domains across organizations, so that if I am, say, a large manufacturer who has part suppliers that I want to be able to give access to my service mesh for particular purposes, I don't have to control their clusters in order for them to have workloads that I can cryptographically authenticate and allow to plug in. So you can work across organizations, multi-net, extra-core, extranet, that kind of stuff, multi-core. So yeah, it gives you an enormous amount of flexibility because it's not cluster to cluster networking, it's workload to network service networking.
Yeah, I see that, but at the same time, you need to receive the configuration for sidecar, right? Assuming that we are still talking that workloads are part of a mesh, right? So sidecar needs to connect to the control plane to receive configuration and to receive certificates for MTLS and so on, right? So yeah, just wondering if you maybe have a thought about this one.
Well, the nice thing is you have that underlying flat L3 connectivity to the control plane is the nice piece about this.
Yeah.
In that your sidecar absolutely has the connectivity to the control plane. I think you're sort of just asking a little bit more about the discovery process. How does the control plane figure out how to phone home? How does the workload figure out how to phone home to the control plane? Is that more what you're asking? Or the control plane figures out how to discover the workload?
Yeah, I mean, because technically we could go both ways, like with our multi-cluster model without the flat networking, that every cluster has a CP and those sidecars connects to the CP in the cluster, but they do not require ingress or egress because we have a flat network, right? So I see this as one option. The second option is to have like a control plane in only one cluster, and every sidecar, every envoy connects to this one control plane where when it is deployed, right? So I think you are muted.
So hopefully, and you're much closer to your own complexity problems, but the part of the point was to, when you start adding additional control planes in every single cluster and start gatewaying them all together in crazy quote ways, the complexity goes up. And so being able to say, here's my control plane, and wherever the workloads happen to be running, they can come up and get what looks like to everybody involved a flat L3 connectivity between the control plane and them, and between them and everybody else, is a real win.
It is true, yeah. I mean, it is very nice. At the same time, a control plane maybe is not a good word in this scenario because users are not really interacting with the control plane in the specific zone. So it's more of an agent, let's say, right? On the other hand, like to counter your argument, is that this one is technically more scalable, can be more scalable if the sidecars are connecting to only agent in the specific cluster instead of going like, you know, over other region or cluster or whatever, especially that the XDS config can be quite big with increasing size of your mesh. So yeah, but this this architecture of putting like only one control plane somewhere is also very very tempting, interesting. Yeah.
So think of it as being able to separate two previously commingled problems, right? Because one set of problems is how do I get all the pieces to talk to each other? The other set of problems is how do I scalably deploy what are effectively caches of my configuration for the endpoints to interact with? And in the traditional model, they're commingled. And here you have the option to separate them in the way that makes the most sense to you.
Right. Yeah. Yeah. Yeah, I can see that how this kind of opens the alternative architectures from what we have right now at this moment.
Any more questions?
One more question. So we had this sidecar next to the workload. Can this be deployed as a daemon set, or is it always a sidecar?
So the NSC
yeah,
sidecar is a control plane sidecar in the sense that all it's doing is monitoring the virtual wire that gives you the L3 connection to make sure that it's alive and to respond with appropriate healing behavior if in fact something goes wrong. The actual traffic doesn't ever get touched by that sidecar, that's the network service mesh sidecar running the pod. It actually goes through a daemon setted thing that does the cross connect between the kernel interface and whatever the tunnels are. So you effectively have a centralized means of just cross connecting. You have a kernel interface in your pod. It goes out to a WireGuard tunnel that carries it to whatever is doing the VL3 stuff. That piece is all part of the daemon set. So you don't. I think part of what you're getting at is how bad is my scaling problem? Adding more sidecar overhead. And the sidecar for network service mesh is literally just something sitting there waiting to be updated every relatively infrequent period of time with somebody saying, we're still here, we're still doing the thing we're supposed to be doing. This is what we think the state is. Doesn't match what you think the state is. Okay, great, we're good. You know, so it's very lightweight. It does almost nothing.
Okay, I see, thanks.
Okay, any other questions?
I guess one question is, what was the motivation to like integrate with Kuma? Was it just to like have all the service meshes tested out with network service mesh, or is there like an actual production push behind it?
I heard about Kuma somewhere even before I have started working on this project. So for me, it was interesting because I also heard about the Istio, but Kuma personally for me seems more interesting and I don't know, for some kind of closer. So yes, that was my personal motivation.
I have I hope it's not a too provocative question, but okay, let's see. So a neighboring service mesh, a friend of ours, he has announced recently this new concept with the zip tunnels and so on. Do you feel like this can be somehow in the same direction? Of course, different approach, but
It's a question of layers, right? So Z-tunnels still presume that you have a flat L3 that you can work over, or you've got a bunch of L7 proxies you can run through other places.
Yeah.
It's the fundamental problem of layers and solving different layer problems. To the previous question, by the way, about motivations, one of the things that's really kind of an ugly mess about service meshes is they tend to be greedy, right? Service meshes tend to want to take over entire clusters at a time. And that's almost always bad architecture. And so if you have a situation where you have someone who is, I see this all the time in orgs. Org 1 at a company has decided they want to go with Kuma, Org 2 has decided they want to go with, Istio. Now what do you do? Well, with network service mesh, I can take individual pods running in Org 2's clusters and give them a connection to the Kuma service mesh without having to move all of Org 2, right? All of the Istio running org. And so it allows for a certain amount of distribution and coexistence. And we also have ambitions of potentially at some point being able to pull the sidecars out into sidecar pods. We're talking about the sort of Kuma sidecars. And we can do that for the sidecars, the L7 sidecars for service meshes, you then have the possibility of an individual workload connecting to more than one service mesh, depending on who it's talking to. And that also broadens the space of innovation that people can play in a very attractive way. And of course, also gives you the ability to lifecycle the sidecars independent of the workloads. I'm sure you've heard of the situations where people are not happy about having to restart their workloads because they need to rev the versions of their sidecars for security reasons or other reasons. So more modularity and flexibility in the system. And of course, that story gets to be more interesting the more different kinds of service meshes are in play as a proof point.
okay, one more question for me. Is there a point to think of, for example, Kuma CP, if I remember correctly, the control plane, to be able to drive some of these, like the NSM part?
So I'll give you the generic answer, and then I'll turn some questions back at you. The generic answer is network service mesh is intensely flexible about what it does. The more that we can get help from the higher layers, sort of hinting downward, that's very helpful. So it would be very doable, the way network service mesh is structured. If Kuma wanted to be a participant, Kuma is the control plane to be a participant, it very well could, and productively. But we also designed so it doesn't have to be, right? Because we want to be able to support people running things on top. I'm curious though, because it sounds like you have some interesting ideas floating around in your head, if you have particular ideas to express.
Yeah, I have to think a little bit more.
Yeah. But I mean, there's a lot to be said about having a single pane of glass from L3 all the way up to L7, particularly when you're talking about a multi-cloud environment.
Yeah.
And that's a very attractive approach to the world.
Okay, I think we're out of time. So that was interesting. Thank you, everyone. Have a good day and see you next time.
Yeah.
Have a good evening
thanks.
or day.
Bye.
Bye.
Yeah.